Hey everyone, welcome to the final chapter of the series. This is Roman Just Codes, I'm Roman, and in this video we'll be taking the project to the finish line. In this video, we'll be optimizing ambient mode to ensure maximum battery efficiency. We'll perform the launcher hack to take over the Watch UI, configure our AndroidManifest for wearos, audit our manifest, and with that, let's get started. Hey everybody, welcome back to Roman Just Codes. I'm Roman, and in this video, we're going to be wrapping up the series. We're going to be talking about the last points that will get your app ready to be published to the Google Play Store for Wear OS. So we're going to be discussing about the home screen launcher, the ambient mode, what it is, what do we use it for, the WatchShape to distinguish between round and square displays on your Wear OS devices, the Google Play AndroidManifest requirements for publishing, of course, which is tied to the home screen launcher. And last but not least, we're going to be discussing about performance, what things to look out for, the gotchas that you need to be aware of, and what things you can implement in order to take advantage of the device's capabilities, not to drain the battery, and to actually make the best of your application when running in these low-power devices. So let's start with the launcher hack approach. So if you see, I'm already connected to my device. So if you see, and then if I, for example, even show you the default application is actually that it comes as part of the factory configuration, you get this watch face in there. But how do I make it so that when I come over here and then I want to make my own application, the one that I just built, always launches every time I open up my device? So the way that you do it is, for example, if you see over here, and then I, for example, like hide the device or something, or I try to come back onto my device, when you always bring it back up, is always that watch face, the one that comes as part of the default One UI watch interface. You want your UI to be there all the time. So the way that you do it, the home screen launcher approach, is that you need to set it as the default app for the home launcher on this device. The way that you do it, and because I'm already connected to my device, this is how you're going to do it. So you're going to go to the settings. You can click right there on settings. You can go immediately to apps. Depending on the version of Android that you have on your Wear OS, the location may differ, but pretty much is the same thing. So you could go to apps, and then you see there's an option that says choose default apps. And then when you click on choose default apps, then here you can find it. There's like multiple options in here, like, okay, what is the default browser? What is the default wallet? What is the default phone app? Like, see, you can have like multiple apps loaded on your device, but this is the one that you're interested about, the home app. If you click here on home app, you see that it says the default home app is One UI Watch Home. No, we want our own app to be there. So what is, why then, if I come back over and then I go back to my home screen, if I go back, for example, like here to the home screen, and then I'm trying to find my application, in this particular case, for example, I just want to have this. Why was I was not able to see it as part of the list of applications that could be designated as the home app? This is the reason. The reason is because you don't have the proper configuration in your AndroidManifest in order to be regarded as a home launcher application. In our particular case, when you went there to the settings and then you went to the apps, you see right here, look, if we go back to apps, and then you go choose default apps, and then you go to home app, there's no clock app right there. How do you mitigate that? How do you make it so that then you can see your app in there? This is crucial because otherwise you won't be able to launch your application. You won't be able to even publish it. When you bring it to the Wear OS Google Play Store, it won't be compatible because you haven't made it as such. So let's go to the AndroidManifest file of this application and let's make some tweaks. So there's a couple of things that you need to take care of before you even publish it, but even just to try it and show it as your home launcher application. Because remember, this is not going to be a watch face per se. It's going to be a watch full-blown Android application that will double up as a watch face. And the way that you do it is you go to your Android. Remember, we're targeting Android. So you go to App, Source, Main, and you go to the AndroidManifest. You go to the main Android manifest right here. And then if you see, this is just any regular Android manifest. But you need to add a couple of lines in here as part of the configuration to designate it as a watch. And also to designate it as something that you can actually load as a main launcher. You need to, it needs to be the default application. It needs to be part of the home launcher applications. How do you do that? The way that you do it is you start by adding this line of code right here. You come over here at the top of the application inside of the manifest. You add this line of code. This line is what designates this watch as a watch application and is like a standalone application that it doesn't need a separate application to work. And this is something that will designate it as a watch. So this is one of the things that you need to have. First of all, in order to bring this application into the Google Play Store, and that it could be identified as a Wear OS application, something that could be loaded on the device. And when you go to your device's App Store, for example, when you go here, and if we come back over, and if we come back to, for example, to the all the apps, or for example, like here on the home page, if you come here to the Google Play Store and then you try to search for your application, it won't show because it's not a watch application. So it's not like you can have like a full-blown application and it will show here. No, it has to be designated as a watch application. The second thing that you need to take care of is the intent filters for your activity, for the main activity. Remember, this is a very simple application. It only contains one activity pretty much, like one screen. And because we're using it kind of like as a headless Flutter engine for our Rive experience. So the way that you need to do is you need to designate that intent on your application. How do you do that? You go inside of your activity. You see how you have like an intent here that it says main launcher. Well, you're missing two more designations in here. Here is going to say that, you know, for example, in this particular case, you can say, okay, it's going to be this is going to be the main activity. It can be launched, and you also want to make it home and default. So these are the two additional designations that you need to have in order to make it officially something that you can load as the home screen. So in the Android ecosystem, the home screen is just another app that listens for the Android intent category home intent. But by adding this to our manifest, we tell the Wear OS that our app is capable of being the primary interface. Also, when you press like the physical crown or the home button on your watch, the system will now offer to set our Flutter app as the default home. So this gives us a massive advantage. Like, we are now restricted by the XML only limitations of the new WatchFace format, but instead of being stuck with static layouts, we have the full Flutter engine, and then you can, at our disposal, you can have complex Dart logic, manage real-time Rive state machines, and even perform network requests or local database operations, do a lot of cool things, tap into other services, other sensors, and capabilities that simply don't exist in the official XML format. And of course, running a full Flutter engine as a launcher requires more overhead than a simple XML file. That's why you need to make sure that, remember, in tandem, you need to have this, the type, the watch. This is the ID card, remember, that I said for the Google Play Store. But by explicitly declaring the hardware type as a watch, we're telling the Android system and the Play Store that this app requires watch-specific hardware to run, and you won't see it anywhere. It ensures that our app only appears in the Wear OS store, and it's just hidden from regular smartphone users. So these are the things that you need to watch out. And of course, like I mentioned, these pieces right here. So now let's try to load it again on the device. Remember, I'm going to kill the application. I'm going to start it again. Let's see now if it shows as part of our home launcher applications. And remember, this is kind of like we're building a WatchFace app on steroids. Normally, an app only has the launcher category, like you see it, because it puts it in the app drawer. But by adding the home category, we're telling the Android OS that our Flutter app is a home launcher. That is the thing, again, one of the things that we want to add. And remember, this is how we bypass the restrictive WFF, the WatchFace format XML requirements. We're not building a watch face in Google's eyes. We're actually building a custom desktop for the wrist that just happens to show the time, pretty much. So let's see when it loads up, and then we're gonna then take a look how we can add it as part of the home. So right now, if you see, the app just loads fine. There it is, but it's still not part of the home. So now let's go back over. I'm gonna go to my settings. I'm going to go back to apps. Let's go back over apps, choose the default apps. And now when I go to the home, there it is. Now I can see my app or custom Flutter application, something that I can designate as the home launcher. So now I'm going to select it. There it is, and come back over. You see that it's actually the default home now. I can go back over to other applications. For example, I can come back to the settings and I can do anything that I want. I can go to the settings, and then even if I come back over, you see how now when I try to dismiss the settings, it comes right back to my custom WatchFace application that I built with Rive integrated, and then you can make it now your watch face. Now when you wear your watch and you bring it up, it will always show your custom face application. Remember, you can add a lot more capabilities to it, but this is the cool thing about that. Let's talk about ambient mode now. What the heck is ambient mode? The ambient mode is actually a widget that is the heart of power management for our Flutter Watch application. On high-end AMOLED displays like the Pixel Watch 2, we can't keep every pixel firing at 60 frames per second forever without killing the battery. So this widget acts as a wrapper that listens to the system's ambient mode events. When the user lowers their wrist, the widget triggers a rebuild. We're going to see that in a minute, giving us a wear mode enum, either active or ambient. And when we pass this value directly into our Rive state machine to swap, let's say, from a full color fluid animation to a high contrast static always on layout that saves power and prevents screen burn-in, this is pretty much what we're going to be doing. It's part of this Wear Plus package. So the Wear Plus package is what actually gives you those capabilities. So it's a plugin that offers Flutter support for Wear OS by Google. And then you can, if you can see right here, you're going to be able to tap into the WatchShape, ambient mode, and whatnot. We're going to talk first about the ambient mode, how to implement it in our widget. So let's take a look at that. How we're going to be tackling the ambient mode. While the watch is active, let's say you're looking at it, you're moving and whatnot, you're going to be in active mode. Then when you, let's say your hand is resting or your hand is down where you're not looking at the watch, then it switches into ambient mode. Let's say when the user lowers their wrist, the widget triggers a rebuild, like I mentioned, and it would get into either ambient or active. Active, let's say you're looking at it, you raise your wrist, you look at the watch, that is active mode. And then when you rest your wrist, you're just going to go into ambient mode. And this is kind of like for, again, saving power, preventing screen burn-in, and we're going to try that. So I'm going to be wearing my watch instead of keeping it on the cradle for like charging. So I'm going to now wear my device. I'm actually putting it on right now. So there it is. You're actually looking at the device, but I'm actually wearing it on my hand. So even when I lower it and I bring it up, nothing happens because we haven't implemented that. But now let's take a look at how to implement ambient mode. So you can see right here that we're only looking whether Rive is loaded. Then we just display the Rive widget. Otherwise, just don't show anything. The way that we're going to implement ambient mode is by actually importing the package first. So I'm going to kill the application one more time. And now I'm going to say Flutter pub add wear_plus. Let's add the package first, and then we're going to bring those capabilities in. We're going to start by using the AmbientMode Widget wrapper. So that is pretty much what we're going to do. And the way that you do it is you actually wrap the whole implementation inside an AmbientMode widget. So that is exactly what I'm going to do. I'm going to just over here do wrap with widget. And this widget is going to be, it's actually a builder. So instead, I'm going to wrap it inside of builder. And then I'm going to call this ambient mode like this. And then if you see the builder gives you a context, a mode, and it gives you, of course, a child. And then if you can see right there, it gives you those three pieces. The wear mode is what actually gets triggered when it switches between ambient mode and active mode, and you can capture that. So what I'm going to do is I'm going to create a local variable all the way up here that is going to be type mode. For example, I can call it wear mode. And then I'm going to make, I'll call it current mode. And by default is going to be active. And that is going to be, for example, like how I will treat my widget is always going to be active unless it changes afterwards. I'm going to capture that value right here. That way you guys can see it and then we can debug it. So I'm going to say current mode equals mode. We can even print it out if you see it. and then it will tell you what the mode is. But you see, at least I'm surrounding my widget, the whole widget, inside of this ambient mode widget. Whenever it triggers from one mode to another, then it will do that. Another thing that I'm gonna do on my device, if you see it, I'm gonna have this always on display. That way you see it even when it's in ambient mode, it will be partially on, like it will still be on, but it's not like it's gonna hide the like just gonna shut down the screen. This is actually to preserve battery. But if you do that, at least for debugging purposes, some people like to have it like that. So I'm gonna keep it as always on. And now we're gonna take a look at that. Let's take a look at the mode here in the terminal as I debug it. And you will notice that when I rest my device, we should be able to trigger that. When, let's say, I lower my wrist and my hand is resting, I would be able to see trigger the ambient mode or the active mode. So you will take a look at it right away, and then we'll see that. So if you see right there, right now I'm looking at my watch and it's in active mode. You probably won't notice it here in this emulator viewer in the screen copy because we're actually viewing our. I'm actually viewing my device. So if I lower my wrist, you see it goes to ambient mode. I raise, it goes to active, lower, ambient, raise it, active. That way, this is the rebuild that we were talking about. So the ambient mode triggers this event accordingly, and then you handle it the way that you want to handle it. For example, in my particular case, let's do something simple, but at least, you know, you can actually come up with a better UI. Maybe you can create a different type of UI, and then you can flip the colors or something like that. In this particular case, what I'm going to do is instead of, so I'll check if I am in current, for example, if my mode is active, I'm going to show, if I say wear mode, that active, I'm going to show my Rive widget just as normal. Otherwise, I'm going to show something simple, such as maybe let's do like a center widget. You know, like let's do center. And then I'm going to do like a text widget. And then I'm going to do like a, you know, like I'm sleeping or something like that. And then we can print out the mode. So I'll do current mode that. Name. Let's make sure that we have the text align, and also let's just make it white just so that we can see it. Here we go. Let's try it again. I'll rebuild the whole application, and now you will see it when it triggers between my main watch face, which is the Rive experience, or the triple Z's. There you go. So that was in ambient mode. Now I'm gonna take a look at my phone, and there it is. Now I'm gonna lower my wrist because let's say I'm in ambient mode, and there it is. So you see it flips between active, and now I'm gonna lower my wrist to ambient. Now back to active, and there it is. You see, you can actually even create multiple experiences, one for active, one for ambient, and you can make something really cool. But this is pretty much it. Active mode is usually when you're looking at your watch. You can definitely like trigger the animations in there, have some complex visualizations. But when you're in ambient mode, you want to preserve the memory. You want to save some CPU cycles. So you want to be more conscious about like which animations, what type of Rive experience you want to do when you're in ambient mode. Now I'm going to look at my watch and back to active mode. So simple as that, we were able to tackle ambient mode, which gives you the wear mode between active and ambient. See, there is because I just didn't do anything. I'm resting my arm and nothing happened. It just automatically triggered the ambient because it's trying to preserve some memory. Cool. So with ambient mode already in place, now how do we apply it to our own scenario? Now I want to apply ambient mode in our custom watch face UI, in which when it's in active mode, it shows exactly the way that you see it right there. But when it's in ambient mode, I want to make it kind of like a monochrome type of style. I want to make it all like light green, but only a single color. That way it preserves the battery and it adopts a UI that is more in line with like low powered experience. So that is exactly what we're going to do right now. So how do we make this experience into an ambient mode experience? So that's exactly what we're going to do. So we already have some of the pieces in place, but what we're going to do is we're going to change the color of everything. So let's take a look at that. Let me go back to Rive and I'm going to implement it over there. So if you see here, this is my Rive experience. So what I'm going to do is actually, what I want to do is I want to change everything to a single color. And that is exactly the power of view models and data binding. We're going to be able to achieve that. So what I'm going to start doing is actually, I'm going to go to my view model, the clock face port view model, and I'm going to add one more property here, which I'm going to make it type color, and I'm going to call it text color. This text color by default, it will probably be white, but eventually what I want to do is I want to make it like all probably like a neon green or something like that, to make it look like it's all like only for like low power devices or something like that, like a monochrome type of experience, but only black and green. So let's try that. By default, I'm going to keep it as white. That's okay. And then what I'm going to do is I'm going to bind this color, this text color property in my view model clock face port, and I'm going to bind it to the properties that I'm concerned about, that I'm interested in, which are, in this particular case, if I go back to hierarchy, I want to do it in the seconds, minutes, and hour. So that's exactly what I'm going to do. I'm going to go to the seconds. I'm going to go and I do data bind, and I'll bind it to this new text color property. Same thing for the minutes. I'm going to do data bind, and then I'm going to bind it to the text color. And last but not least, I'm going to do it to the hour. I'm going to do data bind and bind it to the text color. I also want to do the same thing for this lines right here, like the dial lines. I'm going to do the same thing. That way they all change in color. I'm going to data bind to the text color property right there, and I should be all set. So you say now, why didn't I do it to these ones? Remember, these measurement widgets and the dial measurement dials, they all also are already bound to their own corresponding view models, and those view models in turn have a property called color, so I should be able to leverage that property right there. So why don't we try that? If I try to then say, let's make it like a monochrome type of experience, let's try do that. So with my UI already set up, very minimum amount of work I had to do in order to accomplish this. So let's try it. So I'm going to click it. I'm going to run my state machine, and you say like, okay, everything still looks the same. That's okay. But let's try actually changing the color into that like green luminescent color or something like that. So let's try that. I'm going to change it to this greenish color, something like that. You see everything changed, but I'm going to copy this color and I'm going to paste it across the board on all of the components, all of my view models, and those view models should be able to interpret it. So that is exactly the experience that I want. And even if I change the value, you see that they adopt that color that I've already bound to those components. And the beauty of it was that they were already bound, and all I had to do was just change the color. So that is exactly what we're going to do in code. When it's in ambient mode, we're going to change it to this, or like a similar color like this. And then when you are in active mode, it will show exactly the way you would see it right now, like as normal. So let's go back now with all of this already implemented. I'm going to export this file. I'm going to save you the trouble of seeing that. So I'm going to export it, bring it back in, and then we're going to jump right into the code. Okay, so with my already imported, updated Rive file with all the view models hooked up, with all the bindings already in place, now let's try to implement that in code. So what are we going to do? The first thing that I want to do is I want to set like those default colors that I told you about. I already have them predefined. So I'm going to bring them right up here, all the way up here. I've already defined like what my default colors are for, let's say, for like the text colors, for the dial, for the lines, the dial lines, for what heart rate color would be, calories and steps, and also what the ambient mode color will look like. So it will be like a luminescent type of monochrome, greenish type of color. So that is exactly the colors that I'm going to adopt once I flip the values. But where would I place that? Where would I do that? Remember, the ambient mode will rebuild depending on whether it changes between active and ambient mode. So you need to capture this value. That is the reason why we were capturing this value. So you capture this value, and then you can have, for example, you can have a method called, for example, change watch face mode, and then you pass the mode into it or something like that. Let's create that method right over here, and then I'm going to call it change watch face mode. And then that is exactly what we're going to try to do. So it's already giving us kind of like a hint of how we want to do it. We want to check if the widget is loaded and the VM, the view model, is not null, like it already has been initialized. And then what we're gonna do is we're gonna probably set some properties, local properties in here that will hold those values right there. So I'm going to define a couple of variables that will define those colors in there. I need one for my text color, the HR color, calories, and steps. Now what I'm going to do is I'm going to check if the mode is equals to wear mode dot ambient. If it's ambient is when those values are going to change. And what I'm going to do is if the mode is equals to ambient, then I'm going to change that, right? So I'm going to take a look and then I'm going to reassign those values to the ambient color one, which has been defined above, which is that greenish color. And then if so, that I have all those properties already set and defined and assigned the proper colors depending on whether it's ambient mode or active mode, then I'm going to start setting those color properties. So I'm going to start by saying vm.color. Remember, we're targeting the root text color right here. If we stop it and we come back over, I'm going to tackle the root text color property right here, which is already defined. So I'm going to just go and say text color dot value equals, and then I'm going to assign what the text color is, whichever it is, depending on how it got assigned, right? And then I'm going to try to do VM. Now I'm going to try to access the nested view models, which are in here. Remember the nested view models of calories, HR, and steps, which in turn, they have their own color property right in here. So I'm going to have to go 2 levels deep in order to access this value in there. So the way that I have to say it is dot view model, and then I have to say HR, then I say dot color, and I know that it's actually called color. It's exactly the same color. Now I say dot value equals HR color. I'll populate the other ones automatically because it's pretty much the same thing. But if you see right here, I check. Actually, I need to change this to wear mode, and now we should be good. Perfect. So now that I have that, so I didn't need to look for ambient mode in particular. I need to look for the wear mode and check whether it was ambient mode or active. So now that I have this in here, let's try it. Actually, I'm gonna wear my watch one more time, and then we're gonna deploy it right in place. That way you guys can see it in real time. Okay, so I connected the device. I needed to pair it via wireless. So now let's try loading the application. Then you should be able to see once I load the application onto my device, you will see it there on the screen copy. Once it loads, then you should see it in active mode, and then I'm going to try lowering my wrist so you can see the active mode triggering. And exactly how the code shows here, when the ambient mode triggers, it's going to call this method called change watch face mode. It's going to pass the wear mode into it. If it's loaded already and the VM is not null, then it's going to assign the corresponding colors and then just assign the properties in the VM as such. So let's try that. Now I'm going to lower my wrist, and then if you see, it changes, goes back again to active mode. Now we're back on ambient mode, and you see how it was cool. It actually changes all the colors. Because this is a brand new application, I have to add it back again as being the home screen. So let's try that. And now there it is. This is my default active mode face. I need to ensure that it's always on display. Now this is my default active mode face. And now that is the ambient mode. And it looks pretty cool. It looks kind of like low energy mode type of experience. It makes it look all green. It looks pretty cool live. And then when I then make it come back to the active mode, it just triggers those elements. And if you see, it's actually only triggering when the ambient mode kicks in, but the change watch face mode is capturing the colors and is just assigning the colors to the corresponding view model properties, but it's not rebuilding unnecessarily. It's just rebuilding when it needs to. It makes it very seamless. It makes it in real time. It doesn't consume additional processing power or memory, and it just updates it accordingly. So these are the types of experiences that your users will be able to expect when you build your custom watch face applications using Rive and Flutter. Now let's proceed to the shape of the watch. For example, you can determine whether your watch is round or square, and you can actually take a look to see then which experience you want to trigger. In our particular case, we're only focused on round experiences, like round watch faces. But imagine if you had in Rive one square version and one round version, and then you can publish this application on the Wear OS store, and your users, whether they have, you won't discriminate between a user having a round watch or a square watch. You're going to be able to supply experiences for both of them, and you don't have to do anything other than just add the watch shape. The application will recognize what type of shape it is, round or let's say we'll recognize between round or square, and then the application will react accordingly. You will trigger the corresponding Rive experience. So without further ado, let's go now into that experience. Let's take a look at how that can come about. So the WatchShape widget solves the biggest layout challenge in Wear OS, the geometry. Not every Android watch is a perfect circle. Some third-party devices are square or rectangular. But this widget uses a builder to detect the physical shape of the screen at runtime. This is critical for our UI because a round screen like the Samsung Galaxy Watch 7, like the one I have right now, it has dead zones in the corners. So by using this widget, you can dynamically apply padding or scale. You can scale your Rive artboard accordingly so that our clock elements are perfectly centered and never get clipped by the hardware edges. So let's take a look at that. So what I'm going to do is for now, I'm going to disable this, and I'm just going to keep the active mode. That way it doesn't just keep flipping on me. So let's just stick with the current, you can capture the current mode, but let's just return always this experience. And then all I'm going to do is just show this for now, and then I'm going to try it again. So here we go, so that it doesn't just keep flipping on us. Perfect, there it is. Now let's do the experience on the WatchShape. So the WatchShape is nothing more than another widget that you can leverage in the Wear Plus package, as you can see right here. And then you can do the WatchShape, same thing as the other one. You have a builder method that then you can capture the shape, and the shape is either round or square. So let's take a look at that. So I'm going to do the same thing. I'm going to wrap my whole ambient mode inside of the WatchShape. So let's take a look at that. I'm going to wrap it inside of builder. I'm going to call this WatchShape. Context is the same as the ambient mode builder, which I have a shape, and then I have the child. And then here, all I'm going to do is I can capture the same way. So I have the WatchShape, and then you do Wear shape, current shape, Wear shape.round. By default, is going to be that. So let's do that. Now you can come back down here, and now we can take a look at it. So you can just print it out right here the same way that we had it before. But here I'm going to capture my shape. There it is. And you will know exactly what it is as soon as I reload it. So right now it gives you the ambient mode, and then you're going to see the shape. So if I reload this, and there it is. It tells you exactly that it's a round Wear shape, and it still maintains the ambient mode because it's still triggering, remember, but it's just because I'm not showing that other one. So it gives you active and ambient, but I'm still keeping my same watch face. But what I wanted you to take a look at is that at the beginning, you can then render the experience accordingly. So when it comes to performance in building our WatchFace applications, and when it comes to Rive, you need to take into consideration the following things. For example, Rive execution and frame rates. You need to ensure that you need to reduce the complexity, avoid overlapping too many semi-transparent layers or complex clipping paths. In this particular case, you know that I have a couple of components already loaded, so you need to ensure that. Also, you can ensure that your artboards and your files are pretty lean. Try to keep not too heavy, not that many heavy graphics in it. Even if you're doing SVGs, try to make sure to keep them very simple, very minimal. While in the Galaxy Watch 7, you should manually drop the Rive refresh rate to one frame per second or lower when in ambient mode to save power. So on the Flutter side of things, you need to ensure to avoid heavy rebuilds. Use cons constructors and specialized builders like repaint boundary if you deem that necessary around your Rive animations to ensure that Flutter doesn't repaint the entire screen when only, let's say, a clock hand moves. You could do that. In our particular case, our clock faces are pretty simple, so that's okay in terms of that. But even here, we were not doing that. We were not rebuilding the screen. We're only just triggering periodic timer. And if you saw, we got rid of our set state. The widget, the screen is not being rebuilt other than just the view model properties, which are being updated. Make sure to use simple interpolation. Also, isolate the logic. In this particular case, if you see the way that we did it, we isolated the logic as opposed to keeping it in the build method, but we created our start timer method away from our build method, and we were able to isolate the logic, the time calculating logic, as a separate timer, and only update the specific Rive inputs as needed. If you see right here, by zooming in, you can see I only every time I just update the view model properties and those nested view models, but I don't rebuild the widget per se. I only update the corresponding properties. Also, keep an eye on the battery drain and the screen burn-in. Try to keep your on-pixel ratio, OPR, below 15% in ambient mode. This is why the dark backgrounds like this are mandatory. And of course, if you're ever tapping into network calls, if you're, let's say your WatchFace fetches data like weather, batch those requests. Try to do, constant Wi-Fi and LTE usage will heat up the watch and cause the system to throttle your app's performance. So you also need to take a look very carefully to that. Also, in order to check the performance on your WatchFace application, the Flutter Developer Tools is your best friend. When you're testing, don't just look at the frame rate. You can keep an eye on the thermal state of the watch. If your Rive animations are too complex, then the watch will get warm and the OS will dim your screen or kill your process to protect the hardware. Try to always optimize for the rest state, not just the active state, kind of like the way that we showed you. When we open up the Flutter Developer Tools, we aren't just looking for bugs, we're looking at the efficiency of your watch face on steroids. You can definitely take a look at the Flutter frames chart, and this is your heartbeat. For a smooth 60 frames per second, each frame must be rendered in under 16.6 milliseconds. On a watch, if you see tall red bars, your Rive animations or UI logic are too heavy for the wearable's GPU. Here in the CPU profiler, you got to keep an eye on the total CPU usage. You can also, because high CPU activity generates heat. If your watch gets too warm, Wear OS will aggressively throttle your app's performance or even shut it down to protect the hardware. Also, take a look at the memory heap. Watch for sawtooth patterns. The smartwatches like the Pixel Watch 2 have limited RAM. So if your memory usage keeps climbing without dropping, you likely have a leak in your Rive controllers or listeners that will eventually crash the app. So always keep an eye on that. I always keep this on just to take a look at those things. If the raster thread is spiking, it means that the Rive C++ runtime is working too hard to draw your vector paths. So always keep an eye on that. When we go back here to the CPU flame chart, notice these orange blocks. Those are our Rive renderer calls. If these blocks get too wide, it means our animation is too complex for the watch's processor. Our goal is to keep this as narrow as possible so the CPU can go back to sleep quickly, saving that precious battery life. I also wanted to give a shout out to other packages. Again, like I mentioned, if you want to take this project much further and you want to consume sensor information, this is the package to take a look at. So while we won't be implementing sensor data in this specific series, but the Pulse Kit is a powerful tool for those of you who are looking to take your watch faces to the next level. Pulse Kit is a powerful tool for those of you looking to take your watch faces to the next level as far as streamlined way to access heart rate data on Wear OS, which you could eventually bind to a Rive state machine to make your UI react to the user's physical activity, which is pretty cool. Of course, you need to follow the configuration in here for your AndroidManifest. Also, other things that you need to look at, of course, import this dependency and of course implement it accordingly. Other than that, thank you so much guys for watching this video series on building your own watch face applications for Wear OS using Flutter and Rive. I hope you guys enjoyed this series. I hope you found it really useful. And if you do, please make sure to hit the like and subscribe and alert bell before you go. But always support this kind of content that we're putting out there. Always give some feedback. Please let me know in the comments, what you liked about it, maybe what other series you would like to see. And I hope you can build your own applications to leverage these small wearable devices like the Google Pixel 2 or the Samsung Galaxy Watch 7 and other devices out there. So good luck to you guys. Thank you so much for watching. See you on the next video series. And with that, we've wrapped up the series. We've gone from a blank project to a ready-to-be published WatchFace app using Flutter and Rive. I definitely recommend you taking this project even further and you integrate AI into it, as well as tapping into the sensors available to these devices for even more intelligent data visualizations. Who knows, I might create another series around this. So make sure to subscribe so you get notified when those videos drop. And of course, stay tuned. Thank you so much for watching, and I'll see you on the next series. Hey guys, this is Roman from Roman Just Codes. Thank you so much for watching this video. I hope you found the content in this video very useful, and if you did, please don't forget to like, subscribe, and hit the alert bells before you go. Thank you so much for watching.